So this is these are the questions. The class of IP address can be determined by. So we know that if any address is given to you, we can simply look to the first 4 bits and we can find out that this address belongs to which class. So if it is 0, class A; if it is 10, then 110, then 1110 and 1111. So A, B, C, D, E. So looking to the first 4 bits, we can find out that to which class it belongs. Okay. And also these bits are from the first octet. So actually we have 4 octets are there. 8 bits, 8 bits, 8 bits, 8 bits. So you have to look into the first octet. So the answer is you have to look to the first 4 bits. From the first byte of the IP address, we can find out the class. Okay, this is the answer. The address in the block must be contiguous. This is important. Always, whenever we assign any block, any the range of addresses, it must always be contiguous. Okay, so if I am saying that 100 addresses are assigned to any organization, that means the 100 addresses must be like this. From you can say from 100 to 200. This may be the range, or you can say from 500 to 600. What I mean to say is this is always be contiguous. You cannot say the first is 101, then 120, then 256. Likewise, you have allocated 100 addresses. This is not possible. Okay, we always allocate in the contiguous. Which of the following is a valid subnet mask? Now, here we have 4 options are given. Now, subnet mask are always find out from left to right. Okay, so you have to, if we are moving to the next octet, now these are 4 octets are there. If you move to this octet, that means this is completely filled. If you move to this octet, that means this is completely filled. You cannot find something like this. This is like 128, 255. This is not possible. So first you fill this octet and then you move here. So you can see here. And other part is these are the possible values. 255, 128, 192, 224, 240. Okay, this is 248, 252, 254, and 255. This is actually the first bit, second bit, third bit, fourth bit, fifth, sixth, seventh, and eighth is 255. So these are the possible values. So apart from these values, if you find any values existing here, that means this is wrong. This is not possible, not possible, not possible. Now this is here. What does this mean? It is not possible unless this is 255. You cannot move here. Okay. And the second way, this is also not the possible values. Now this is correct. 255 and then 128. So this is the subnet mask possible. Now, which of the 2 statements describe the IP address? So if we look to this address and we look to the options, actually we need to know the entire information regarding what is the first address, what is the last address, what is the range of address. So if we know this information, then only we can look to these options given to us, and then we can make a decision. So this is given to us. So let us find out what is the first and last address. We need to find out the information of this block. So here n is 23. So what is the mask? So the mask 23 means this is 16 plus 7. So that means 255, 255, and 7 means 254.0. Okay. So then we find out the first address by doing the AND operation with this. So what do you find? You find 10.16. And if you do this, this is actually a 7th bit. We have used 7 bits. So 254 is actually what? You have used 7 bits, you have used, and then 0. And this is what? The last 2 bits, 2 and 1. That means this is the common. So you write 2 and 0. This is the first address. And what is the last address? The last address you can find out by using this. We will do the not of this. So not of this is 0.0.1.255 and 10.16.3.65, and now we do the OR operation. So this is 10.16.3.255. So the first address is this, the last address is this. Okay, it will go from 16.2.0 to 16.3.255. So the network address is 16.2.0. So the first address is the network address and the last address is the broadcast address. These two addresses are not actually used. Okay, so but this is a network address. This is correct. The first host address. So the first host address is actually 10.16.2.1, because the very next address will be the first available address. We know as a property, the first address is the identity of the network and the next address is the available host address. So this is not correct. The last valid host address. So the last valid host address is just before this. So this is the broadcast address. So we will do 10.16.3.254 is a valid host. So this is 2.54. This is not correct. The last host address of the subnet is 10.16.3.254. This is again correct. So we have 1 and 4 is correct. So this is the answer. So moving to the next part. Which among the following is true for some networks in the classful addressing? So whenever we do the subnetting in the classful addressing, there are two conditions are there, that number of subnets will always be in the power of 2. Means if a block is given to me, I can make here 2 subnets, I can make here 4 subnets, I can make here 8 subnets, 16 subnets. That means it must be power of power 2, right? So sorry, power of 2. Okay, so means I can make 2, 4, 8, 16 subnets I can create. This is first condition. And how many addresses are possible? Again, in each subnet we can have only addresses which is again a power of 2. Means we can have 2 addresses, 4 addresses. You cannot make any subnet of size 9. This is not possible. If I want to make a subnet of this much requirement, then definitely I will make a subnet of size 16, because 16 is the next nearest value, which is a power of 2. If I want to make a subnet of size 5, then it is not possible. I will make a subnet of size 8, because this is a possible value. So both conditions must be desired. Number of addresses must be power of 2 and number of subnets must be power of 2. So both 1 and 2. Now assuming the classless addressing, if the first address of the block is this, the last address is this, then what will be the prefix value for this block? Okay, so the first address is given to us and the last. So we need to find out how many addresses are actually existing in this block. So 230.8.24.63 is the last address and the first address is 230.8.24.0. So we will subtract this 0.00 and here you get 63. Okay, so how many addresses are there? If you remember, we discussed some numerical, so you have to add. So this is 0 to 63 is plus 1, that is 64 addresses are available in this block, and 64 addresses means this is what? This is 2 power 6. Okay, so 6 bits we have actually used here. Now so we have, then what will be the value of prefix value for this block? So we have a relationship between the number of addresses and prefix, that is n. Number of addresses equals to 2 power 32 minus n. So we can say this is actually if you take a log both the sides, so log n equals to 32 minus n, or you can say the prefix is prefix equals to 32 minus log n. Okay, so 32, and what is n? N is the number of addresses. How many addresses we have? We have 64 addresses. Okay, so what you get? You get here 6. So what you get? 26 is the value of prefix here. Okay, moving to next question. Okay, in class B, subnetting is done with subnet mask 255, 255, this, how many subnet and hosts it provides. So when I say class B, so class B means this is 16 plus 16. 16 is the network bits, and this is the host bits. And whenever we do subnetting, subnetting is always done on the host bits. Okay, so in the class B, this is the structure with subnet mask 255, 255, 224. So class B subnet is actually 255, 255.0.0. And because we have and use the subnet mask, this thing, that means we used these many bits in the host part to get this 224. And how to get 224? 224 is what? 224 is possible with the 3 bits. So if I use 3 bits from the host ID, then this can be done. So how many subnets and host it provides? Because the subnet mask is 224, that means I used 3 bits. So subnet bits uses 3. Okay, so how many subnets can be formed? So subnet you can form 2 power 3, that is 8. So 8 subnets can be formed. So out of these 4 options, we have this and this are the possible options, right? Because we have 8 subnet and 8 subnets. How many hosts it provides? Now here I can say host, not the addresses. So host means total addresses minus 2. So how to find the addresses? So addresses you can find out. Now we have 16 plus 3. 16 plus 3 is 19. So 32 minus 19, or you can say that out of 16 already you have 3 you have used for subnetting. So how much is left? 13 is left. So how many addresses are possible? 2 power 13 addresses are possible. So 2 power 13 is somewhere 8192. And because we are looking for number of possible hosts, you must be remembering that out of all the possible addresses, 2 addresses are not used because the first address is the network ID and the last is the broadcasting address. So we can use only 8190 hosts are possible. So this is the answer. 8 subnets and 8190 hosts are possible. So this is all question that actually I need to discuss with you.